Hi guys, because I know you're so excited and you enjoyed that redox equation video, I thought I'd also remind you, you do have to predict products, okay? And you have to write net ionic equations. So I'm going to start with some net ionic equations here. This is a double replacement. You would have to predict the products. Now first thing, I would check the solubility rules, and I would check this out to see if it's aqueous or solid. This bad boy happens to be aqueous, okay? It's because potassium is an alkali metal, okay? This guy is also aqueous because nitrates are always aqueous, so that's good. So now when it comes together, it makes KNO3, which is aqueous, cool. Plus, okay, as we come over here, this would be PbI2, because Pb is plus 2 in this situation. And if you look at your solubility rules, this bad boy is a solid. So how do you write a net ionic equation for this? Here's what I do. When it's a double replacement, it's nice and easy. These aqueuses break apart, and if they're on both sides, they're spectators. So this is going to be on both sides, so no K over here, no K over here. Okay? Oh, I didn't balance it. I should have. I need to put a 2 here. And then I need to put a 2 here. Okay. All right. And nitrate, it's over here and it's over here, so we don't need those. So now, only the stuff that we didn't cross out is going to make it to the net ionic equation. 2I minus aqueous, because we're just breaking those into ions, plus Pb plus 2 aqueous makes PbI2 solid. Now I could have broken each one of these up, okay, and I could have, and that's the main goal of it, but that's just messy, and why when it doesn't take that long to do it this way? So that's a reminder, net ionics are fun. All right, let's take a look at another one, maybe a single replacement. First things first, a single replacement, you have to think and look at your activity series. Is magnesium higher than hydrogen? Okay, so you would look, magnesium definitely is, it will replace hydrogen, so it'll become Mg, and I'm going to put a 3 here, PO4 2, plus H2 gas. Okay, there's our nice equation. Now, I want to now do states of matter. Magnesium at room temperature is a solid. This is a acid. All acids are aqueous. Strong acids completely dissociate. This Mg3PO4, I would have to look at my solubility rules. And it's a good thing I have my solubility rules right here. And I go down here and I look for PO4, alkali metal. So this is going to be a solid. This bad boy is a solid. Okay? All right, and this guy is a gas. Cool. All right, so what can break up? Just this guy. And it should break up. And can anything else break up? No. So this becomes a big, fat, huge, pain in the booty net ionic equation. Nothing's really going to cancel out. There are no spectator ions. So I'm about to do this, but before I do, I want to make sure everything is balanced. So I'm going to put a 2 here to make sure my PO4s are balanced. And then I need to make sure my hydrogens are good. And I'm going to put a 3 here. So here's what it really looks like. 3 Mg solid plus 6 H plus aqueous plus 2 PO4 minus 3 aqueous yields Mg3 PO4 2 solid, because those don't break up, plus 3 H2 gas. Oh, weren't those fun to remember? Should we do another one? I don't have another one off the top of my head. Here, I got one. I can think of one right now. How about if we did magnesium plus HCl? This will go the same way, except it makes MgCl2, and that's aqueous, okay? Plus H2 gas. Now this is also aqueous. This is a solid at room temperature. So now we have to get rid of our aqueous, okay, of our aqueous situation. So if I were to redraw everything out, Mg solid doesn't break down, plus H plus, oops, I keep forgetting to balance, 2H plus aqueous plus 2Cl minus aqueous yields Mg plus 2 aqueous plus 2Cl minus aqueous plus H2 gas. If you take a look at this, ladies and gentlemen, the only thing, okay, that's on both sides, the spectators, is this Cl minus. So we get rid of it, and we rewrite this equation. Mg solid plus 2H plus aqueous makes Mg plus 2 aqueous plus H2 gas. Oh my gosh, doesn't that look like a redox equation? Isn't it amazing? Couldn't you do half reactions? This is going from 0 to plus 2. Oil, rig, oil. If it's going from 0 to plus 2, magnesium is being oxidized. Hydrogen is going from plus 1 to 0, so it's going down. So hydrogen is being reduced. Oh, it's amazing. But this one's balanced, so we don't have to worry about it. All right, I hope that helped, and I will see you tomorrow. Bye.